let's talk about how, now that we've gone over what the intermolecular forces are, how they kind of apply to real life. So the first thing we're going to talk about is something that's called surface tension. And so liquids tend to want to actually stick together to minimize the surface area that's exposed to air. So what that does is that's going to kind of create a skin. Have you ever seen the little water bugs that can crawl, on water? They're walking on the water. They are walking on this because of surface tension. The surface tension of the water. The water wants to stick together because ultimately a puddle only goes out so far when you spill it. Water beads up if it can. Another way that you can see intermolecular forces is the concept of viscosity. Viscosity is how well a liquid does not flow. So if something is highly viscous, it doesn't flow. If something is low, it has a low viscosity, it flows well. So it's a little bit backwards than what you might think. So viscosity is going to be greater in substances that have stronger intermolecular forces. So just think of something like honey. Honey is kind of a real viscous sugar. So think about how it's thick, and you have to try really hard to kind of get it to come out of the bottle. Something that's doesn't have a high viscosity, like rubbing alcohol or hand sanitizer or something. It's going to flow fairly freely. So the sugar molecule in honey is a very large molecule, and there is some branching there, so they're just going to kind of stick together. Rubbing alcohol, it's a real small molecule. There's some polar stuff that goes in there. Now, if you've ever dealt with honey or pancake syrup and you want it to flow better, what do? I hope you said you put it in the microwave, because that would be correct. So viscosity decreases as the temperature increases. So you heat it up. Now, why would that be? So when you're heating things up, the molecules are going to be moving faster, and the faster they move, the less sticky they are to each other. They're not going to have as much time to interact with each other to be sticky. Viscosity, also kind of sticky is a good word for that. And then the last example that we'll talk about is capillary action. Capillary action is the ability of a liquid to actually flow against gravity up a narrow tube. So if you've ever given blood, or where they do a blood sample where they kind of prick your finger, or even if you have to like check your own blood sugar or something, they'll have a big tube, or the test strip of a glucose test strip will actually use some capillary action, but they'll have a long, real narrow, maybe about as wide as the end of this pin here. So it's real narrow, and the blood actually goes up. So here we need to determine the difference between some of our adhesive forces. So what you have to have, the first one are adhesive forces. These are between the liquid and the surface, meaning the wall of the tube. So adhesive forces. So you have to have some of those. So the liquid has to be attracted to the molecules of the tube, because it needs to stick to them. And then you also have cohesive forces. This is how, because this is going to have its ability to climb up. Cohesive forces are the molecules of the liquid itself. So how well did they stick to each other? Now, most of the time, capillary action also has to do with the forming of a meniscus. So remember, the meniscus that you generally look at has, like, this is water in like a burette, a graduated cylinder, anything. You always read it at the low point of the meniscus. So here, this is adhesive forces, and then within the tube, these are cohesive forces. So in this case of water in the meniscus, the adhesive forces are greater than the cohesive forces, because even where the water stops, it keeps climbing on up the tube. Mercury, on the other hand, forms a meniscus that looks like this. So this would be probably Hg2 liquid. Liquid mercury, these here, it sticks more to itself than it does to the edge of the tube. So this, in mercury, the cohesive forces are stronger than the adhesive forces. It still climbs, but the meniscus looks different.